Good morning. Today I will discuss one of the important chapters which is called Aldol Condensation reaction. Aldol Condensation. This reaction involves the reaction of an aldehyde containing alpha hydrogen or ketone in presence of dilute alkali to form beta hydroxy aldehyde or ketone. As for example, this is an aldehyde containing alpha hydrogen plus dilute NaOH to form alcohol. Now here actually two molecules of aldehyde or ketone will be used, right? Now, if I take a ketone, here it will be used baryta, barium hydroxide. So special kind of apparatus will be used in this case because ketone is less reactive than aldehyde. So special type of apparatus will be used, that is Soxhlet apparatus. Now the product will be here beta hydroxy ketone. So this is alpha and beta. This is alpha and beta. So beta hydroxide ketone is formed, here beta hydroxide aldehyde. Now the name aldol is called because an aldehyde group is present and an alcohol group OH group is present. That is why it is called aldol. Now, what is the mechanism of this reaction? Mechanism. The mechanism is that first one molecule of aldehyde, if I take aldehyde, the starting material, in presence of base, that is, it will abstract alpha hydrogen, one of the alpha hydrogens, to form enolate. CH2 minus CH. Now this is enolate. Okay, this is again stabilized. Now this enolate acts as a nucleophile. The second step is that these enolates reacts with another molecule of aldehyde that is this nucleophilic carbon attacks this carbonyl carbon to form an adapt. O minus CH2 CH2. Now subsequently this will this anion this anion will abstract a proton from water to form this electron. Get that. Now this is your Aldol product. Next slide. Now if I take an example, this aldol, aldehyde molecule, and if it is treated with dilute NaOH and followed by heating. Now what will be the product form? The product form will be first this aldol is formed, followed by elimination of water. The alpha beta unsaturated aldehyde is formed. Alpha beta unsaturated aldehyde is formed. Right. Now this aldol reaction is catalyzed by number one acid, another is base. So base catalyzed Aldol condensation already I have given with mechanism, but acid catalyzed Aldol condensation reaction is that here the product is alpha beta unsaturated aldehyde or ketone is formed. So let us take an example. Say already I have taken this ketone. If I take one example, this ketone, and if it is treated with HCl, that is acid catalyzed reaction, it is treated with HCl. So here also two molecules of ketone will be used. Now first in a similar way, that is beta hydroxyketone is formed. Beta hydroxyketone is formed, followed by elimination of water. Now in presence of acid, water will be eliminated from this hydroxyl group and it will form this alpha beta unsaturated ketone. So here no heating will be required. In presence of acid, alpha beta unsaturated ketone is formed. Now what is the mechanism of this reaction? The mechanism of this reaction is that HCl strong acid will give up H plus plus Cl minus. Now, if I take the ketone as a substrate, so first protonation will be done from this oxygen atom to form this complex. During this formation of complex, the electrophilicity of this carbon will be increased. Now, the second step is that the ketone. Second step is that the ketone, in presence of acid, it forms an enol. How? Say if I take this ketone and in presence of acid, this enol is formed, because enolation also carried out when the enol is formed in presence of acid. This intermediate is formed. Now with this enol, another molecule from the ketone, this enol reacts with this carbon and attack will be this hydroxy followed by subsequently, that is so this will be reacting with this proton, and the Cl minus, it will abstract this beta hydrogen. After elimination of this water, it will form this kind of alpha beta unsaturated ketone. Alpha beta unsaturated ketone. So this is the mechanism of acid catalyzed aldol condensation reaction. Now this aldol condensation reaction can be of two types. One is called intermolecular aldol condensation. Reaction. Another is intramolecular aldol condensation reaction. Now, intermolecular aldol condensation reaction is that when two different aldehyde, when taken as substrate, and when the same dilute alcohol is treated, we can have four different products. From this self aldol, and then cross product will be formed. So what are the products will be formed? So from each aldehyde, this aldol is formed first, last. From this also self aldol is formed, plus two cross products are formed. What are the two cross products? From alpha hydrogen from this, so this carbon is formed first. So this will attack this carbon to form this aldol, beta hydroxy aldehyde, OH, from this alpha hydrogen from another molecular aldehyde. So it will form this aldehyde, aldol, plus from this alpha hydrogen, that is this alpha carbon ion, that is that this carbon ion will attack with another aldehyde molecule. This will attack this another aldehyde molecule to give another aldol. So these are the cross products. CH2, CHOH, CH2, CH2. So these are the four different products we will form if I take two different aldehydes. Similarly to if I take one example of aldehyde and ketone, so I can give you another example, that is one aldehyde plus one ketone. So in presence of dilute alkali, here also four different products are formed. CH2, COCH3 plus in a similar fashion, that is basically the alpha hydrogen will be abstracted by phase and that acts as a nucleophile, and that nucleophile attracts the another molecular aldehyde or ketone, whatever you have taken the substrate. So it will form the corresponding. So these are the cross product. Cross product. This is also cross product. Plus self aldol from each molecule. So this is formed from this self Aldol condensation reaction, and from this also we can have flash. Now the major product in this case, first step, this alpha hydrogen and this alpha hydrogen is also there. So two different kinds of substrate is there. But basically the base, although the aldehyde is more reactive than ketone, the first the base will abstract this alpha hydrogen to form this enolate. This enolate is a beta carbon ion donor. If I take the carbon ion from this ketone, it will act as a beta donor, beta nucleophile, beta donor. better to know. So this will first attach this more reactive aldehyde to form this cross product. This cross product. Okay. Then carbanion form from this aldehyde molecule, and the major product first from these two crossover product. This will be the predominant one. This will be the predominant one between these two cross products. Okay. So this is the intermolecular aldol condensation reaction, and if I heat this mixture, if I put heat, so here alpha beta unsaturated aldehyde and ketone is formed. Now let us take an example of beta hydroxy aldehyde or ketone, and after heating, what is the major product is formed, that is to be discussed. Now, so if I take this is one of the crossover products in the previous reaction. Now after heating, so two products are formed, alpha beta unsaturated aldehyde ketone. So from this CH2 double bond C CH3, CH2 CuHO, and from this side here also there is chance of formation of this alpha beta unsaturated aldehyde. But this is the major product, because this alpha beta unsaturated ketone is resonance stabilized. This is a conjugated system actually. This is a conjugated system. This conjugated the CO group, but this is not a conjugated system. That is why this is the major product. Now another class of reaction, that is intramolecular aldol condensation reaction. So in this case, that when a dialdehyde or diketone in a compound is treated with a base, that is intramolecular cyclization reaction takes place, followed by the elimination of water to form alpha beta unsaturated ketone or aldehyde. So let us take an example. Let us take an example that is the example of intramolecular aldol condensation reaction. So here two diketone is taken in a substrate, and if it is treated with similar reagent. Now what will form first? That so 1, 2, 3, 4, 5, 6, 7, 8. Now first step is the formation of carbon ion, that is alpha, that is carbon ion. That carbon ion is formed from either this side or this side. Okay, means either from C1 or C8 side or C3 or C6. Now when the carbon is formed from this alpha hydrogen, that will first abstract to this carbonyl carbon in a single molecule, not another molecule, to form a 5-member ring. 1, 2, 3, 4, 5. 5-member ring is formed. Now, what is the 5-member ring? If I write this 5-member ring is formed, so minus, and after that it will take up proton from this water molecule. It will form this ketone. It's not aldol, ketone. Okay. Ketone is formed. Now, when it is heated, this alpha beta unsaturated ketone is formed. CO3. Now this is major product. This is major product. Now there is another chance of formation of carbon from either this C1 or C8. So when this carbon is formed from this side, so definitely it will attack this carbon, and what is the this attack is formed 1, 2, 3, 4, 5, 6, 7 member ring is formed. Now 7 member ring is formed. The 7 member ring is formed. Plus 2 plus 3 plus 4 plus 5 plus 6. Okay. So this 7 number ring is formed. So I have taken from this 1, 2 as like this. So I have numbering. I have done this numbering from this 1, 2, 3, 4, 5, 6, 7. Now after elimination of this water, it will form personally alkene. Alkene that will happens. The alkene is formed. But the stability of, as we know that stability of stability order in cyclic ring system, that is 6 member ring is more stable, 6 member ring is more stable than 5 member ring than 7 member ring. So where the previous example 5 member ring is from, that is why the major product was 5 member alpha beta unsaturated ketone. That's all for this Aldol condensation reaction.